This is a beginner Blender Python tutorial where we'll be checking out Python classes. I'll go over what Python classes are and show you some examples of how you can use them in your code. Hey, I'm Victor Stepanoff. I'll be guiding you through this beginner Blender Python tutorial. Today we're going to be taking a look at Python classes. We're going to check out what Python classes are, how you can use them, and then we're going to check out some examples. We're going to be using 3 ways of organizing the code. So we're going to use some step-by-step, then we're going to use some functions and some classes. The examples are going to do the exact same thing, but they're going to be organized in 3 different ways. So what are Python classes? Well, it's all about how you organize your code, meaning that you can organize your code in a number of ways using functions, just using step-by-step instructions, and then classes. So you might ask, well, can I not use classes at all? And actually, as a beginner, you can get pretty far without using any classes. And I would actually recommend you do. But then you're going to say, but why am I even watching this video, Victor? It's like, what's the point? Well, the point is that we need to learn a bit about classes to work with Blender add-ons. Because if we take a look at the templates and then add-on object, you can scroll down and you can see right away we're using a class right here. So I would like to give you just a basic understanding of what a class is before diving into any add-on examples and videos. In all our scripts, we always work with data and some kind of behavior, or we always transform some data into another piece of data. For example, we have some coordinates for vertices. We use those coordinates to create a mesh, right? It's all about transforming data into some other data using some functions. For example, we have a function right here, and then we have some data that defines verts and then defines faces using the indices of those verts. And then we just pass in that data into another function and so on down the line. This is all about working with data and some kind of functions, right? A class is all about combining that data and that behavior together. So it's all in one place. So you don't have to worry about when you copy something around that you'll be missing some data or some part of your code. You can think of classes as blueprints for a house, and then you create an instance of that class, which is called an object. So using a single blueprint, you can create multiple objects. You don't really have to create multiple objects, you can create only one, but the option is there for you. Something that you'll hear quite often is this acronym called OOP, which stands for Object-Oriented Programming. I'm underlining object here because you're going to be defining classes that create objects and work with them. So everything that you see in your code, you would create an object for and then work with that to organize your script. So how do we use these classes? Well, we'll take a look at how you can define a class, how you can create an instance of a class, and then use that instance. So here's an example of a class. We have the class keyword, which is very important to tell Python that we are starting to define a new class. We have the name, which can be anything, but it can't start with a number or use any spaces or any special symbols in the name. Then we have a very, very important function, the _init_, which is a thing called a constructor. Constructor always runs when you create a new instance of a class. So we initialize the data of a class before we are ready to use the rest of the functionality. Then usually you would define some kind of data in the constructor and then use it in the functions or so-called methods of that class. We have the ability to pass in parameters into the constructor, so we can set, for example, a name or any other data that we want to change when we're initializing a new object. Notice that we're using self a lot here. We're using it as the very first parameter to every single method in a class. Something important to note is the set of data for each instance of a class. So when you create an object, it's going to have its own set of data, and it's going to be independent of other instances of the class. So you can change the data of one object without worrying that it's going to change other instances of that class. So this is where the self comes in. It refers to the current instance that we're working with. It'll make a bit more sense once we start looking at some examples. Also, if you're feeling a bit overwhelmed here, don't worry. When I was starting to work with object-oriented programming years ago, I also had trouble wrapping my head around this concept, but eventually, after practice and using different examples, I got it to a good place. So don't worry if you're in that place as well. It's totally okay, and it's pretty involved concept. So to create an instance of a single class, you use the name of the class, and then you provide the required parameters that, remember, we defined in the constructor, right? This right here. And then we just create a new variable. So we assign that object into the variable. Next, we just use that variable to call the methods of our class. And notice that we're not using any self right here. We did define it in the definition of the class, right? But we don't need to use that once we're actually using the instance. Python handles that for us, automatically passing in that self around. Also, notice that I'm not changing the data of the class directly. This is one of the features of a class that you'd actually want to use to make sure that if you have some kind of issues and you're not sure where the data is changing, if you always exclusively use methods of a class to change the data, then you can quickly find issues that way. So let's take a look in the interactive Python console how this all looks. So I hope you will follow along. I'm in the scripting workspace, so if you scroll all the way to the right and click on the scripting workspace and make some room right here, I'm going to make this text a bit bigger. And I'm going to just maybe make it a bit more bigger. So I've just pasted in this definition of a class right here. You can go ahead and copy this as well into your interactive Python console. Remember, don't leave any new lines or spaces in between these definitions in the interactive Python console. You can do that in the text editor, but the interactive Python console doesn't really like when you paste in that code this way. Also, notice that I've added into the constructor at the very end a print statement that is going to tell us that, hey, this ran. You're going to see this in just a second when I create an instance of that class. So I'm going to create a new instance of the example class. And notice right away, as soon as I ran this code right here, it printed out that message that we have right here. So the very first thing, as soon as you create an instance of a class, it's going to run this init method right here, and it's going to initialize our data. So let's use our object. And you can see the example method will print out the data that we have. So it's the example param that we're passing in, remember right here, so 1, 2, 3, and this is exactly what we're printing out. Next, we can use the get example data and assign the result to some variable, maybe print it out. Let's do that. Actually, you know what, I'm just gonna print it out like so. Just gonna return it, and we can set it as well. So I remember I defined a set method. So right here we got a set method, and we're passing in some value and setting the data through that. So let's do this. So I'm gonna write that and then set it, and then let's see and let's get that example data. And look at that, as soon as I set the data, all that is hidden behind the scenes for us, and we can just use these methods to control the data inside of an instance of a class. Okay, now let's take a look at an example. I'm going to be using some code that I have a video on how to create a cube mesh just using some Blender Python commands. If you want a detailed explanation of what's going on there, check out that video. But for now, I'm just going to use that without going into depth what exactly is happening. So I'm going to update this code right here. And this is the code. We're defining some verts, some faces, then we're creating some data, so some mesh data, and creating an object out of that mesh data, and then linking that into the scene like so. I'm gonna delete everything from the scene, and then let's run this code. And you can see that we have a cube added into the scene based on our code right here. So this is the step-by-step method, pretty straightforward, nothing really fancy. We're just executing we're creating some data and then executing some commands using that data. Now let's take a look at exactly the same code but written in functions. I'm going to paste that in. So again, this code is going to do the exact same thing. It's going to add a cube into the scene. And that's it, but it's organized a slightly different way. So you can see that I have these functions now. I've moved each one of these calls into a more readable function name. And let's go at the very bottom. So we have a main function that's getting called as soon as we run the script. So let's just run the script. You can see it's adding the same cube into the scene. And if we take a look at this function right here, again, we're defining some data and nothing really changed from the previous example. Defining some faces, and then we're passing in all that data into another function. So let's take a look at this. It's defined right here. We're using these verts, edges, and faces, and we have 3 other functions that we call here. We create the mesh data, then we create the mesh object from that data, and then we add our mesh object into the scene. And all these 3 functions are defined right here. Again, pretty straightforward in the sense of we're just hiding the functionality under a function. And the main idea here with functions is you're just focusing on a small piece of code and just really kind of zooming in and trying to understand if there's an issue in this part of the code or not. Okay, let's take a look at how this would look if I would use a class. And let's go at the very top. And right away you can see that I'm using the init method, and I'm defining the verts and the faces and using the self to store those values into the instance of that object. Also, I'm keeping track of the mesh data and the mesh object as separate variables. I'm setting this to none, so it means that it's not really set just yet. We can use this in these methods to check if our instance is in a particular state. Don't worry if this is not making a ton of sense. It will once we get more examples going with these classes. And again, you can see that this didn't really change much compared to the example with the functions. The only thing that I'm only passing in the self right here, and I'm using a self to get the verts instead of passing in the verts. I know that the verts and the faces are part of the data of this class, so I'm just using that to I'm leveraging that to create the data and assign it right here. Then I'm using this mesh data that we have here and again creating the mesh object, and then we're again using that mesh object through the self. So I'm using the self to pass in that data along and adding this into the scene. So right here we're just calling those 3 functions, so this is like a recipe. And at the very bottom in the main function, we're creating an instance of this class. And then we're calling this method right here. And we're using a particular location, so we can put this cube in any location. And we're checking if we actually created, we've already added this object into the scene, because we can, nothing's stopping us from doing this right here, right? We can call this 2 times, and calling it a second time would be an issue, right? Because we've already added, and this is what I'm checking right here. As soon as we initialize this once, this won't be equal to none, so we're going to skip it, and we're going to print out a warning like, hey, by the way, you probably shouldn't be doing this here. You're adding this mesh object again into the scene that you've already added. And then we're just setting the location of that mesh object. And let's run this just to make sure it still works. I'm gonna remove that. And you can see we're getting the same exact scene in 3 different ways. All right, let's take a look at a couple more examples. And don't worry, all these code examples are going to be in the description, so make sure to check out the description for these examples. They will be numbered. All right, the second example is going to be, I'm just adding more to the first example. So this is the code for the first example, and this is the step-by-step method of describing the code. And right underneath that, after we add our object into the scene, I'm going to define a cube with triangle faces. So right now, this if you enter edit mode, you can see that the faces are just squares. I actually want to define the cube with triangle faces. So the main thing that I'm changing here is the definitions of the faces. So I'm using the indices to set each face, and just continuing to add the object into the scene, and then changing the location on the Y. So let's run this code. I'm going to delete everything from the scene, run it, and let's take a look at this. So this is the square faces, this is the cube with the triangle faces. Again, you can see that we have some code here that is getting repeated multiple times, and we want to try to avoid that, right? So now let's take a look at the example with the functions. All right, so this is the example with the functions, and the main thing that changed here is I moved the cube verts outside of that original function, right? Because we're going to be reusing this 2 times. Because the vert coordinates won't change for both of these cubes. And the main thing here is with the triangles, I'm defining the faces, right? And I'm just using this create mesh object function that we defined before, right? Again, this is pretty similar to what we had before, but we're not defining the verts. And you can see that all this code above is not really changing from the very first version of this example. All right, let's delete everything and make sure that it creates the same scene. All right, let's take a look. Yep, it's creating the same scene, but just the code is organized in a different way. So now let's take a look at how all this looks with classes. I'm going to paste in that example code. At the very top, I'm defining a cube class that's going to be used for the cube with the square faces and the cube with the triangle faces. You can see that I'm only defining the verts here. I'm leaving the faces list as an empty list, and I'm not really touching the other methods in this particular class. Now I'm using something that's called inheritance. So you can inherit methods and data from other classes. So you can see that the definition of that original class with the cube with the square faces is now only just one single init method, right? So this is the syntax right here. I'm inheriting from this cube class, so the class that's defined here, that's the name, right? And I am just defining the faces, and that's it. This is a very important thing here. This actually runs the init method of that parent class. And the same thing goes for the cube with the triangle faces. Again, it's inheriting from that cube class. And again, the code here is minimal, so we're using a lot of code here, right? We're calling that init function of init method of this cube class and just defining the faces, right? And right here we're creating the instances of these cubes right here, and the only main difference with the triangle face cube is we're setting the location on the Y right here to 3. So let's delete everything and make sure that this still runs. And this does. This is square faces, and this is the triangle face version. We can actually draw a diagram of the inheritance of these 3 classes. So it would look like this. So you can see we have the parent class as the cube and the other 2 cube classes inheriting all that data and those methods and just reusing all of the functionality and data. And if you're learning something new or just enjoying this tutorial, make sure to give this video a like. I'll greatly appreciate it. Let's take a look at the final example that we're going to take a look today. And in this example, again, we're going to start off with a step-by-step instructions. Again, you can see that this code is getting pretty big, right? We're repeating a lot of code over and over again. And I want to say one thing about the step-by-step method. This doesn't mean that you don't need to use this method of writing code. Actually, I would highly recommend for a beginner to start this way. In this way, you can clearly see that, okay, these instructions are read and executed from top to bottom, right? It's totally fine to experiment with things in this way. I don't want to say that the step-by-step method is worse than the other methods. It has its uses. So if you're comfortable with this way of writing scripts, it's totally fine. You should continue doing that. And when you're comfortable with this way, you can slowly transition to using functions and classes, right? So in this example, in this final example, we're just adding more code at the very bottom of the script. We're creating a pyramid with triangle faces, and we're defining the verts, the faces, and just running the same code, just moving the object on the Y on the 6 units like so. And then probably the main thing that changed here is these names of the data and the object itself. So let's delete everything and run the script. And you can see that we have these 3 objects going on, right? And that is it. So let's check out how this looks with functions. And this is the main function right here. Again, nothing really changed since last time we looked at this. The main thing that that we added is this function right here, and we're moving that pyramid on the Y. So let's take a look at this pyramid function. Again, defining the verts and the faces, and then calling and reusing that create mesh object. The main thing here is that we're adding a new parameter called name, and we're using this name right here in the the cube with the triangle faces and the square faces, right? And let's just scroll all the way up. So we added this name, and then using this right here to define the mesh data, right? We're using the formatting, the Python formatting with the F, and then using this syntax right here to convert this variable into a string like so. The same thing goes for this right here for the mesh object. Okay, let's try to run this. I'm going to delete everything and run it. You can see that we are successfully creating the same scene, but now using functions. Let's take a look at how this would look with classes. So right here, we can again just take a look at the main function. At the bottom, we're using a new class that's creating this pyramid and moving that pyramid on the y6 units. And then we're using this interesting statement right here where we're using this shape and then instance count. We'll take a look at what this is in just a minute. So let's scroll all the way up. And right here, I decided to define a new class called shape. So it's going to be defining our cubes and the pyramid. And nothing really changed, except again, we're passing in the name. So we need the name here of that shape. And also one thing I've decided to add as an example of a class variable. So not only class instances could have data, so this is the data that's getting passed around inside of a single instance of a class, right? There's also a way to attach data to the class itself. So you're attaching the data to the blueprint like of an object. And here I'm just counting the number of instances, right? The number of times we created a shape. So at the very beginning, when we run this code, this is going to be 0. And each time we create a new instance of this class or use it, this is going to increase by 1. So when you run this code and you take a look into the system console, you'll see that this will be equal to 3. So let's actually run this right now. And you can see it's creating the same scene that we've seen before, right? And let's take a look at into the system console. And let's look at that. And you can see that since we called that class 3 times, right? So these are all inheriting from that shape class. This returns 3. All right, let's take a closer look again at the shape class. It has everything that the original cube class had, right? I just moved all that functionality and just renamed it to shape. And now we're just using the name, again, using the self, remember, to access the data of the current instance. And all of this is pretty similar to what we had before. Now here we're defining the pyramid class. Again, the thing that we need to pass in is now the name. And we actually need to redefine the verts and the faces for the pyramid. For the cube, we're inheriting from the shape. So again, pyramid is inheriting from the shape as well. So the cube is inheriting from the shape. We're defining the verts, passing in the name, right? And we're continuing to just inherit from the cube, right? So see, we don't really need to these two square classes, the square face, the cube class is the one with the square faces, and the one with the triangle faces doesn't even know that it needs to define some kind of new name because we've handled it right here. All right, so that is probably the main thing that I wanted to show you. Again, the inheritance of these classes looks like this. So again, if you are feeling a bit overwhelmed, that's totally fine. This is a pretty complex subject. Again, we're going to be taking a look at more examples so you can get more comfortable with this. We're going to be taking a look at some add-ons that's going to use classes. So hopefully this will give you a better insights when we're going to be taking a look at that. And before I summarize what we did here, I want you to recall at least 3 things that you learned today. This way you could start solidifying that knowledge that you gained today in this video. So go ahead and pause the video and say those 3 things out loud. Maybe write it down on a piece of paper or maybe write it down in the comments. All right, let's summarize what we learned today. We took a look at what Python classes are, how you can define a Python class, how to create an instance of a class, and then how to use that instance. And if you're still feeling a bit overwhelmed, go ahead and ask some questions in the comments to this video so I would know exactly what you're struggling to understand. I'll try to do my best to make some follow-up videos and explain things you don't understand. All right, make sure to check out my Beginner Blender Python tutorials playlist where you can find other beginner videos. And for more tutorials and videos like this, make sure to subscribe, and thank you so much for watching.